Alright, people. Today's topic is logarithm. First of all, we need to know what logarithm is. Let's write a number as index form. A to the power of x is equal to y, let's say. This is called index form. I can write this function as logarithmic function. How do I write it? Logarithm a base y is equal to x. These two functions, and this is called logarithmic function. These two functions are the same, exactly the same. Here, a is called base. Now, what does that mean really? 2 to the power of x is equal to 8. This is index form. And I would like to find out what x is. But there are different ways of finding it. But can I write this as logarithmic function? Absolutely yes. It's going to be logarithm 2 base 8 is equal to x. So this is how we find the unknown power. Okay, we are not going to solve it now. It's just I'm trying to explain what it means. This is index form, and in order to find the unknown power, I can write it in logarithmic function. We can easily evaluate this. Okay, now let's start laws. What are the laws of the logarithmic functions? The first and the most important, logarithm a base of b. This is a logarithmic function. And a and b must be greater than 0. They can be 0.1, they can be 0.05, but they can never be negative number. They can be any number more than 0. Number 2. Logarithm a base of b is equal to c. So how do I convert this in the index form? A to the power of c is b. This is logarithmic function, this is index function. We commonly use this rule. A to the power of c is b. Number 3. Logarithm a base 1 is always equal to 0. Why is that? Let's prove that. Let's say logarithm a base of 1 is equal to x. How do I write it as index form? A to the power of x is equal to 1. Can I write 1 as a to the power of 0? Yes, a to the power of 0 is equal to 1. Why did I do that? Because I would like to equalize the base. If bases are equal, same, and two functions are equal, then the power has to be equal. So x is equal to 0. So it means that if you are given a question and ask you to evaluate as logarithm 5 base of 1, what are you going to write? 0. You don't need to write any of this. You can directly write 0. Number 4. Logarithm a base of a is always equal to 1. Why is that? Let's prove it. Logarithm a base of a, say that equal to x. How do I write it as index form? A to the power of x is equal to a. I am using this rule here. How do you convert logarithmic functions into index form? A to the power of x is equal to a. What is the power of a? 1. Bases are same. Two functions are equal. Power has to be equal. X is equal to 1. So what does it mean? It means that if you are given logarithm 3 base of 3, both of them are equal, then you can directly write 1. You don't need to show any of these steps. The answer is 1. Number 5. Logarithm a base of b plus logarithm a base of c. Both of them are a base logarithm. Then I can combine them. Logarithm a base e times c equal to. Number 6. Logarithm a base of b minus logarithm a base of c. You got two logarithmic functions have the same base and there is subtraction in between. Then I can write them as logarithm a base b over c. Number 7. Logarithm a base b to the power of c. If you have a power, you can move that power in the front of the logarithmic function. C times logarithm a base of b. That's equal to. Number 8. Logarithm a base of b. I can write it into two logarithmic functions. Logarithm b over logarithm a. Now you can ask, teacher, you didn't write any base here. If there is no base written, you need to know that it is 10. The base is 10. But we don't write in mathematics base 10. So you need to know that it is 10. Okay, now let's solve the questions. Evaluate the first. The first question says here that logarithm 2 base of 16 is equal to what? So logarithm 2 base of 16. Let's say that is equal to x. Then how do I write as index form? 2 to the power of x is equal to 16. 16 is 2 to the power of 4. Same base, the power has to be equal. So logarithm 2 base of 16 is equal to 4. Number 2. Logarithm 1 over 100. Now what is the base here? Is there any base written? No, there is no base written, but we know that the base is what? The base is 10. So let's say that is equal to x. Then how do I write it as an index form? 10 to the power of x is equal to 1 over 100. Can I write 1 over 100 as 100 to the power of negative 1? Yes. Can I write 100 as 10 squared to the power of negative 1? Yes. Then power to power, what do? I multiply them. 2 times negative 1 is negative 2. So 10 to the power of x is equal to 10 to the power of negative 2. It means that x is equal to negative 2. Number 3. Okay, the next question is logarithm base 125 of 5. This is equal to x. So how do I find it? Let's write it as index form. 125 to the power of x is equal to 5. 125 means 5 cubed to the power of x is equal to 5. Power to power, what do? We multiply them. 5 to the power of 3x is equal to 5. What is the power of 5? 1. Same base number. It means that 3x is equal to 1. X is equal to 1 over 3. So that's the answer. Okay, next. Number 4. Okay, here, number 4. Number 4. Was it A, B, C, D? No, it was number 4. What is the question? Logarithm 5 base of 1. Remember the rule? If the number here is 1, doesn't matter what base it is, the answer will be 0. So you can directly write 0. Number 5. Logarithm 3 base 243. Let's say that is equal to y. So how do I write is index form? 3 to the power of y is equal to 3 to the power of y is equal to 243. We know that 243 is equal to 3 to the power of 5. So it means that y is equal to 5. So logarithm 3 base of 243 is equal to 5. Number 6. Logarithm 100,000. So what is the base here? There is no base written, but we know that that is 10, right? Say that is equal to x. Then how do I write this as index form? 10 to the power of x is equal to 100,000. 100,000, can I write it as 10 to the power of 5? Absolutely can. There are 5 zeros, so 5. It means that x is equal to 5. So logarithm 1